So talking about chromium oxidations. So chromium oxidations are the really harsh oxidations. They're the ones that will keep oxidizing things. They won't stop. So PCC is the one that stops, only does one oxidation, but chromium will oxidize all the hydrogens attached to the carbon bond oxygen. So the first step, mechanism of this I wanted you to know was chromic acid, which is this right here. The first thing it's going to do is actually going to get protonated. So there's H plus in the system. So what that's going to do is make the chromium that much more electrophilic. We need it to be reactive because the chromium is actually going to react with the alcohol that we want to oxidize. So I have a primary alcohol here. So by protonating the chromium, right, I made this, by protonating the oxygen, I made the chromium more electrophilic. Right, the plus charge is here, but really, right, the metal is electron deficient. Right, Lewis dot structures, they can lie to us. So what happens? The oxygen is the nucleophile. It reacts with the chromium. It adds in, it breaks that pi bond. Right, so the oxygen added in, we got balance our charge, an overall positive charge here. We need to have a positive charge in the next step. So the oxygen lone pair goes there, so we have a plus charge on this oxygen right here. The next step is just a proton transfer. So you don't really need to have a mechanism for this. Essentially what happens is the hydrogen that was on that oxygen is going to be transferred to another one of these OHs. It doesn't matter which one. All right, so again, we balanced our charge. So the hydrogen that was here ends up on this oxygen over there. So that makes. All right, so the next step is going to be we're going to kick out this water. So the electrons between this OH bond, we're going to regenerate the acid essentially. These electrons will come down, and then I'll kick out the water. That's an elimination step, right, that we've seen before, like remaking the C double bond O. C double bond O CR. So following that step, we just regenerated H plus from here, and we kicked out the water. So again, we're going to protonate the oxygen and the chromium. So the lone pair here is going to be the nucleophile, and that's going to react with the H plus to protonate that chromium. So same as that first step, and that's just going to make that chromium just more electrophilic. So similar to what we did before, but now I have a different structure on there because I have the alcohol now attached. You know, at the end of the day, we knew we were trying to remove these hydrogens. That's what the oxidation part is. So the water is going to come in and play and take one of those hydrogens. And that's what's going to give those electrons to that chromium there. That's what's going to first make that oxidize that first bond off. That first CH bond has now been removed. And so now we're with an aldehyde. So I want you to know up to this point. That's all I want you to know up to this point. So the keys that I want you to remember, you protonate the oxygen and the chromium with H plus, right? If there's H plus around, you need to use H plus, right? So the lone pair of the oxygen takes that H plus. That makes the chromium that much more reactive for the alcohol to react with it, right? You do a proton transfer, you get water, which is a good leaving group, right? So you remake the C double bond, CR double bond O. You also make H, so you reprotonate again, and now the water, instead of reacting, right, with the chromium, you're going to use this reactive chromium to get electrons now because it's electron deficient, right, because you protonated it. The oxygen in the water is going to take the H. Those two electrons are going to form a new pi bond. And the bond between the oxygen and the chromium, those electrons are going to go to the chromium now. So then it leaves. Yep. So right. So anytime it's a oxidation reduction reaction, the carbon here got oxidized, right? It lost the CH bond. The chromium got reduced, right? It lost a CO bond or a bond to oxygen, right? This carbon got a bond to oxygen. This chromium lost a bond to oxygen. So this got oxidized. The chromium got reduced, right? At the end of the day, look at chromium's getting electrons. It's getting reduced. It's getting electrons. This carbon's this carbon's more bonds to oxygen is getting oxidized. So this is, I want you to know this first step. Now it keeps reacting, right? This aldehyde and the mechanism you don't need to know. chromium's going to keep reacting with this and turn this finally into a carboxylic acid. Right? It's not going to stop here. If we wanted to stop it here, what would we use? We'd use PCC. But chromium is going to actually turn this into a carboxylic acid.